Good morning, everyone. Today we are going to discuss on how to find the electric field to an night sheet by using calculus. So basically, we are not going to use Gauss law, and we are going to use calculus as a main weapon to calculate the electric field due to an night sheet. There are first of all you have to know the formula for the infinitely electric field due to infinite long wire or infinite line of charge, which is 2k lambda by d. It is a basic necessity to find it through calculus. Okay, so what I am going to do here is just I am going to take a sheet of sigma charge density. Okay, this sheet, it is extending to minus infinity here, plus infinity here, plus infinity here, and minus infinity here. So what I am going to do is just I am supposing it is the center of that sheet. From center, I have to find electric field at this point. This is the key point at distance d from the center. What I am going to do at x distance from the center, I am going to take an infinitely long wire of dx thickness and try to write the electric field due to this wire at this key point. Okay. So what it would be? It would be perpendicular to that wire and it would be in this direction. And this would be 2k lambda by, so this is 90 degree. This would be under root d square plus x. So let it let make it clear for you. So this is the central point that I have taken. This is P and this is at 90 degree. So this is D and this is X and this is root D square plus X square. And this is the electric field in this direction. Okay, so it will be 2k lambda under root d square plus x square under root d square plus x square. Okay, we're going to take components. So if this is going to be theta, this is also going to be theta. Now this component is going to be 2k lambda under root d square plus x square cos theta, and the value of cos theta is d square plus x square under root d square plus x square. That's great. It is d upon under root d square plus this is the value of cos theta. So if we are going to write the small electric field over here, dE, in a vertical direction, it would be 2k lambda under root d square plus x square into d under root d square plus x. We don't know the value of lambda yet. So what is lambda? Lambda is charge per unit length. I know sigma. This is a sheet of sigma charge density plus sigma charge density. So what I am going to do, sigma is charge upon area, So for instance, it can be written as Q L into L. Okay. So what I am going to do here is to make it like this. I'm going to multiply it sigma with dx. So what I am doing here is this. This is the length of the wire. Lambda is charge per unit length, and that is the dx thickness. So if I want to write its lambda, what I am going to do, I am going to multiply the sigma, which is q l into dx, with a dx to make it lambda. I hope that I made it clear. So it would be 2k sigma d dx d square plus x d vertical. So we are going to integrate it from 0 to e, and it from minus infinity to plus. Okay. What we are going to take x as? We are going to take x equals to d tan theta, and dx would be d sec square theta d theta. So dE 0 to e equals to minus infinity to infinity 2k sigma d dx upon d square plus x square. I am going to substitute x equals to d tan theta, which is dx equals to d sec square theta d theta. If I put infinity over here, it would be pi by 2, and minus infinity would be minus pi by 2. I must be sure that you would be aware of the nature of the graph of tan theta. It goes like this. Okay, here is minus pi by 2. Here is that. Okay. So it would be 2k sigma dx की जगह in the place of dx we will put d square sec square theta d theta. Here we are going to put d square tan square theta. This is going to be cut out. This is going to cut out 1 plus tan square theta, 1 plus tan square theta equals to sec square theta. So this whole thing going to cut out this. I am left with 2k sigma d theta minus pi by 2 pi by 2. The integral will give me 2k sigma pi. The value of k is 1 upon 4 pi epsilon naught. So it would be sigma upon 4 pi epsilon naught 2 pi. So it is pi 2. So it is sigma by 2 epsilon naught. This is going to be electric field total in the vertical direction. What about horizontal direction? It would be 0. Reason is quite simple. Suppose that I have taken the element from center in this direction. So its vertical component going to come out in this direction. If I am going to take element in this direction, then its vertical component is going to come. Its horizontal component going to come. If I take in this direction, horizontal component going to come in this direction. And if I go to a component in this direction, its horizontal component going to come in this direction. They both are equal, so they both will cancel out. So there will be no electric field in the horizontal direction. So electric field due to infinite long sheet of sigma charge density equals sigma by 2 epsilon. Thank you.